I can't say it's our last video, Algebra 1 students, but we're getting there. This is the last one before your quadratics and radicals test. So we're going to go through and do some problems. Let's look at what I'm asking you to do for the directions. Okay, there are the concepts that are covered on this test. Factoring. Use solving quadratic equations by factoring, by taking square roots, by using the quadratic formula, by completing the square. By graphing could be added in there as well. Even though I didn't include it on the list, but that is another method that we will use to solve quadratic equations. Graphing alone, by itself, finding the axis of symmetry and vertex of a parabola. Simplifying radical expressions that include variables. Simplifying cube roots. Although we looked at ones with variables in class, you will only see numerical ones on the test. And solving word problems. Should say solving, continuity, Lecomte, continuity. Should say solving word problems. Involving quadratics or radicals. And so I picked some problems out of the book and then a couple of extras. Let's take a look. I picked page 593, 1 to 17 odd. If you go ahead and you do those before you watch the video, or you can pause it and do them as we go. Whichever one. I do not want you solely watching the video. I know some of you are going to do it anyway, and I can't do anything about it, but that's not what I want. I want you to actually do the problems first. So let's start doing them so we can get this done. Graph each function. Well, what I'm actually going to do here, because you can use your graphing calculator just fine to graph them, I'm going to go ahead and practice finding axes of symmetry and vertex. So let's look at number 1. Okay, and remember, we are doing the odds here. So axis of symmetry, the formula is x equals negative b or opposite of b over 2a. And in this circumstance, our b value is 0, a is 1, b is 0, and c is negative 7. So I know a few things about this particular parabola. The first is that the axis of symmetry is going to be 0, because if b is 0, I have 0 over 2 times 1, which doesn't matter. So your axis of symmetry here is x equals 0. Your vertex, if we plug in the 0, sorry, having a little technical difficulties. The vertex, when you plug in the 0, the y value is going to be negative 7. 0 minus 7. So the vertex is 0, negative 7, and then you could use your calculator to find a table of values. You could also go ahead and find that table of values by hand. I put 0 in the middle. I'd put negative 1, negative 2, 1, and 2 in there. When you plug in negative 2, I think you get a 5. When you plug in a negative 1, you get a 4. Plug in 0, you get negative 7, like we already found. Nope, negative 4. Sorry, negative 4. So I plug in 1, you get negative 4 again, and then a 5. I mean, so we can do this part by hand, but I can use the table on my calculator as well. So being able to find the axis of symmetry in the vertex here, that's going to be the most important part. Let's practice that with number 3 as well. So axis of symmetry, x equals the opposite of b over 2a. So this time, a is negative 2, so negative 2x squared plus 10x, so b is 10, and c is negative 1. So the opposite of 10 is negative 10 over 2 times, and our a value is negative 2. So this is not going to come out happily. It's going to come out to negative 10 over 4, negative 10 over negative 4, excuse me, which is 5 halves. So when I then go back and I plug in 5 halves as my x value, this is a great example of where I can use my graphing calculator to help me out a little. Although if I don't have one handy, as in the case of doing homework or me making a video, I do actually have a graphing calculator somewhat handy. It wasn't that far from me. But I can do the math without the graphing calculator as well. I'm just saying it's more convenient to have it. And I'm going to use math enter, and change it to a fraction. I'm going to get 23 halves. So I have a vertex of 5 halves, 23 halves. Now the reason that this is still actually an okay example of a problem to do here, for us to oh, there's our axis of symmetry. So axis of symmetry, vertex. Still a good example because when I go to find a table of values, you can put your 5 halves in the middle, and you have a number that is, you have numbers that are halfway, that are equidistant from 5 halves, 2 and 3, because 5 halves is 2.5. So you could use this table of values just fine and use your TI 84 to help you with the rest of that problem. So the graphing, not as much an issue. It's really, make sure you know how to find your axis of symmetry and your vertex by plugging in that x value. Let's continue on to solving some quadratic equations. You're going to see a variety of types of problems for you to solve. Some of them you can factor, some of them you can't. We're going to go ahead and do 5, 7, and 9 on this page. Starting with number 5. X squared plus 11x minus 26 equals 0. Factors of negative 26 that add up to positive 11 are going to be positive 13 and negative 2. So this is not a difficult one. Remember then that you use your zero product property. X minus 2 equals 0, so x equals 2. And x plus 13 equals 0, so x equals negative 13. Now do make sure you write that out, because if your factor was 2x minus 2, you would want to make sure you recognize that the answer here would not be 2. The solution would not be 2. It would be, if 2x minus 2 equals 0, and we add 2 to each side, we get 2x equals 2, and then divide by 2, we get x equals 1. So do make sure you use that zero product property so you can see the answer. It's very easy to mix up answers in your head if you try to do it all mentally. Number 7, x squared minus 19x plus 80 equals negative 8. We're going to add 8 to both sides, giving me x squared minus 19x plus 88 equals 0, which is again factorable. Factors of 88 that add up to negative 19 are negative 11 and negative 8. So these are not super difficult questions that I picked, which is why at the end you're going to have a couple more problems for us to go ahead and solve, so we can look at ones that don't come out nice and happy with whole number or integer answers. How about number 9? What's different about number 9 from the others that we have here? There's no linear term. We can take square roots for this one. So I'm going to add 100 to both sides. Add the 100 to both sides. We get this. Remember to divide off the coefficient first before you try to square root it. We seem to come up with this answer all the time. Remember that it's plus and minus 5, not just 5. So positive and negative 5. If we want to do specific and be specific and use the right notation, we should have it in curly braces, which means I should go back up to this one and write it like that too. All right. That's not bad at all. We don't have that much left to do here. And then you'll be ready to start studying for your test. Word problem. We're creating a rectangular banner for a school pep rally. You have 100 square feet of paper. You want the length to be 15 feet longer than the width. So we want length to be 15 plus the width. So the width would be W. What should be the dimensions of the banner? Well, area is length times width. So in this case, that would be 15 plus W, or W plus 15, times W. And I'm going to put the W in the front just because it looks nicer. And we want that to be 100 square feet. And that's the equation we're going to solve. So these quadratic equation word problems tend to have basically the same format each time. You're going to be doing some sort of operation that has you getting a quadratic term, giving you a quadratic equation that you can then solve. I'm going to subtract the 100. So we have one side equal to 0. I'm looking for factors of negative 100 that add up to 15. And those are positive 20 and negative 5. If I then set those equal to 0, I'm going to get negative 20 and 5. Well, the banner can't possibly be negative 20 feet long. That's not going to work. But it could be 5 feet in one dimension, and then 15 plus 5, which is 20, in the other dimension. So it's 5 by 20. 5 feet by 20 feet, if we want to even be more specific. That was a pretty easy one. This is an interesting set of directions. We're just going to actually solve the equation that we got here. Okay, we're just going to actually solve this. But they're asking us to find the number of real number solutions of each equation. What they're asking us to do is to tell, well, if I try to solve this, am I going to get real numbers, real answer solutions, real number solutions or not? Are they going to be non-real numbers? Well, I'm noticing that I could take the square root here because there's no linear term. So if I do that, I'm going to have x squared equals negative, x squared equals negative 8 because we're subtracting 8. And then when I try to take the square root, mayday, I can't do that. That's not going to work because I can't take the square root of a negative. So this does not have any real number solutions. No real number solutions. And the question is, knowing that there's no solutions to this can be done multiple ways. The way I just showed you. What's another way? We could graph it. And we get this parabola where this is 8. And so you notice a startling lack of x-intercepts. Okay, lack of x-intercept. Okay, next one. Solve each equation if necessary, round to the nearest hundredth. Well, here's the thing. They didn't do a very good job with this in the textbook because you can actually factor 15 and 17 still to solve them. So you're not going to end up with answers that have to be rounded to the nearest hundredth. So I thought that was a little awkward that they insisted on having it, setting it up that way. So I want to remind you that the easiest way to do this kind of problem would be to move both those terms to the right-hand side so that the 3x squared is positive. That means I'm going to have 3x squared minus 7x minus 10 equals 0. And then I want to factor that. You could also use the quadratic formula and it will come out nicely, but I'm going to factor it. Now, I know that it's got to be 3x times x. And I just want to point out how difficult it can be to figure this out without using your AC and B method. I now have to figure out what the factors of negative 10 are that fit in here to get this particular circumstance in the middle. So rather than trying to do that, I'm going to go ahead and use the AC and B method. I need factors of negative 30 that add up to negative 7, which are negative 10 and 3. Negative 10 and 3. So negative 10 and 3, so we're going to split up our middle term into minus 10x plus 3x. Minus 10 equals 0. Divide out the GCF, leaving 3x minus 10. There is no visible GCF, so we use a 1. 3x minus 10. So I have x plus 1 and 3x minus 10. And this is a perfect example of where you really need to write out 3x minus 10 equals 0 and add 10 to each side. And then divide and get 10 thirds. And for this one, we just get x plus 1 equals 0, so negative 1. So there's my two solutions, negative 1 and 10 thirds. And then we have this one over here, number 17. I want you to look for ways to make your life easier here. There is a GCF of all of these terms, and if you take it out, you have a much nicer problem to solve. So if I divide off of 4, it leaves me 3x squared plus, 3x squared plus 4x minus 7 equals 0. I can keep I can just divide the 4 off. Because remember, I'm not factoring completely, I'm solving. And then I want to factor 3x squared plus 4x minus 7. So I want factors of negative 21 that add up to 4, which are going to be 7 and negative 3. So 3x squared plus 7x minus 3x minus 7 equals 0. Take out the GCF, leaving 3x plus 7. GCF here is going to be a negative 1 to leave me, again, 3x plus 7. So be careful with the sign change there. X minus 1 and 3x plus 7 are my factors. Looks really similar to the previous problem, giving me 1 and negative 7 thirds. So I know that what's going to happen is this is going to flip signs, and then we're going to divide by that, negative 7 thirds. But we need to do a couple more. So let's take a look at another page, and I'll go ahead and get an image in here we can use. And we're going to look at some problems where we are simplifying or solving, some equations where you're not going to have nice, happy answers. So we'll just do 2 of them. Let's do 1. And the other one we can do is 3. So we'll do 1 and 3. All right, so x squared plus 8x plus 1. Clearly, I can't factor that. I can't find factors of 1 that add up to 8. So I'm going to use the quadratic formula. So the quadratic formula, remember, is the opposite of b plus or minus square root of b squared minus 4ac all over 2a. And I will let you use formula sheets when you take your test. So the opposite of b is going to be negative 8 plus or minus square root of b squared, so 8 squared, minus 4 times 1 times 1, all over 2 times 1. And make life easier. Take just this portion, put it in your calculator, or do it out by hand because this is an easy one. 8 squared is 64. 64 minus 4 is 60. So right now I have negative 8 plus or minus the square root of 60 all over 2. And when you do that, you're going to use your calculator because that's the path of least resistance here. You have to remember to worry about your order of operations. So I like to go ahead and just do negative 8 plus the square root of 60, get an answer, and then divide by 2 after that. And that comes out, if I'm going to go ahead and round it off, let's say to it says give exact answers where possible, or to 4 decimal places. Shenanigans, 4 decimal places. Let's round to the hundredths place. That's what we decided to do in class most of the time, hundredths. So that's going to be negative 0.13 for one answer, and negative 8 minus the square root of 60. Enter, and then divide by 2, enter, is negative 7.87. So negative 8 minus square root of 60 all over 2 comes out to negative 7.87. And then we'll do one like 3. Well, 3 is another one where I'm not going to be able to use factoring because there are no factors in negative 2 that add up to 6. But I'm going to use completing the square for this one. So I've got x squared plus 6x. I'm going to move the 2 over to the other side. I'm adding a number to complete the square. I'm adding 6 cut in half and then squared. 6 cut in half and then squared. So 3 squared, 9. So I'm adding 9 to each side. Factor that. It's x plus 3, the quantity squared. It equals 11. Square root both sides. Remember to put a plus or minus in front of your root 11. And then subtract 3. So x equals negative 3 plus and minus square root 11, which is a little bit easier than the other one because we don't have to worry about the fraction. So negative 3 plus the square root of 11 is 0.32, approximately 0.32. And negative 3 minus the square root of 11 is negative 6.32. Negative 6.32. So there's your 2 solutions there. And that's it. That's what you need to know for this test. Practice solving quadratic equations, practice simplifying radicals, and I'll see you guys in class next time for the test.